Okay, so this video is to finish the backside of your bank paper of notes. And on the front side video, I said that I introduced what a unit vector was, and then I'd said I'd talk about it more later. Well, now it's later. So problem number 4 says that I want to find a unit vector in the direction of v, which is negative 2, 5, and then I need to verify that its magnitude is 1. So the first thing I need to do is I can't change the direction of v, so I need to keep the ratio of the negative 2 and the 5 the same. But I can reduce that ratio. So I need to find the magnitude of vector v first. So magnitude is the distance formula. But since this is in component form, instead of doing the distance formula, I really can kind of cheat and do Pythag. So I'm going to do the shorter way. So negative 2 squared plus 5 squared, all square rooted. So you're going to get, or you should get, the magnitude of vector v is the square root of 29. So now that I know the magnitude, I'm going to divide both pieces of vector v by this magnitude. So my unit vector is going to be negative 2 over the square root of 29, comma, 5 over the square root of 29. So that's my new unit vector. The only thing that we really could do is we could rationalize this. So one step better would be negative 2 square root of 29 over 29, comma, 5 square roots of 29 over 29. So this is the unit vector, and I'm going to label it. It's vector v, but I'm going to put a little u, a subscript u, because it's the unit vector of vector v. The last thing I need to do is I need to verify this new thing that I have in blue has a magnitude of 1. So to do that, I'm going to do a different color. I'm going to find the magnitude of vector v unit. So that's going to be big square root, quantity negative 2. I'm going to use the unrationalized version because it'll make things a little bit easier. But you'll get the same answer either way. Just going for the path of least resistance and least amount of work. So when I clean this up, I'm going to get a square root of 4 over 29 plus 5 over 29. Oh, sorry, 25 over 29, which is going to get me a square root of 29 over 29. And you just verified the magnitude is 1. That was awesome. Okay, so the next thing we're going to do is we're going to find the direction. So the next thing we're going to do is we're going to find the direction of a single vector. So we have two examples here. And you can read what's on the side, but I want to explain this to you as logically as I can. Vector u and vector v, we'll start with vector v because the components are different. Vector v, these are in linear combination, has a component form of 3, -4. So its x is 3 and its y is -4. So if I know something's x and y, then I can use tangent, because tangent is y over x, to find its angle. So that's exactly what I'm going to do. I'm going to start with a, though. So for 6a, I know that my x is 3 and my y is 3. 3, 3. So I want to find the angle of this vector. I'm going to do tangent of theta equals the y, 3, over the x, which is 3. And I know you're going to tell me I'm crazy for this, but I need you to do something for me. Before you do anything more, you always should draw a quadrant plane and circle where this should be. And what I mean is, in this problem, the x is positive and the y is positive, so your answer needs to be in quadrant 1. And I'll explain why in a couple seconds. So I'm going to go back to the problem. I have tangent of theta is 3 over 3, which is 1. And you can grab a calculator and do this, but I'm just going to use a little bit of logic. Tangent is 1 at the 45 degrees because it's root 2 over 2, comma root 2 over 2, and that's where tangent's 1. So I know in this case, I need a 45-degree angle, but it's got to be the one in the first quadrant. So my answer in this case is going to be 45 degrees, or pi over 4. And I agree that tangent's also 1 in the third quadrant, but that would have been a -3 and a -3, which is exactly why we circled our quadrant. I want the 45 degree, but it has to be in the first quadrant because x and y were both positive. Sorry, trying to shrink everything so I can do the next one. Okay, so now let me do 6b. So 6b, same idea. I am going to write it in component form, so 3, -4. The x is positive, the y is negative. I have to be in this quadrant down here, so quadrant 4. So I'm going to do tangent of theta, and it's going to equal -4 over 3. And that's not a unit circle value, so you're going to grab a calculator, and you're going to type in the calculator arctan. Of -4 over 3. If you're using my classroom calculators, they are all set in radians, so your answer is going to come out in radians. So you're going to type -4 over 3, and your radian answer would be -9.927295. I'm going to take that answer, I'm going to multiply by 180, and then divide it by pi, and you should get that theta equals -53.130 degrees, and that is in the fourth quadrant, so we're in the right place. So find some white space really close to this problem. I want to make up one more. I'm going to say that I have vector r, and it equals -2, 5. We did this earlier, so I'll use a similar vector. So I want you to try to find this angle, but I'm just warning you, there's a little trick. So once you've tried and you think you have an answer or you're stuck, start the video again. Okay, so before I start, I'm going to circle my quadrant. It's got to be in quadrant 2. So tangent of theta is going to equal my 5 over my -2. I'm going to do arctan of 5 over -2. And so if I type it, my radian should have been -1.19029. You should multiply by 180 and divide by pi. And so now you should be looking at a theta that is negative 68.1986 degrees. The problem with this and the trick in this problem is the following, and this is another reason why I told you to draw it. This is down here. Because remember when we did arc functions, which is what we used right here, we had the hot lava over here. When you do arctan, you're never going to get an answer in the second or third quadrant, so we had to do a little bit of math. I know that I need to be negative 68 degrees below the line, but I need to be the same thing in this quadrant. So it's going to be negative 68 degrees, or 68 degrees above the line. So really what you're going to do is 180 minus your 68.1986. And that's going to get you your answer to make sure that it's in the proper quadrant. Oops. So your theta in the second quadrant is 111.801 degrees. Okay, so before I do this page, we need to have a little talk, and I feel like I did this in the other slide, or the other video, I'm going to do it again. You need to know the difference between a scalar and a vector. A scalar is just a number. No direction, no label, no nothing. A vector has not only a number, but a direction. And if you think about Despicable Me, in Despicable Me they say that the villain Vector, he says that I have both direction and magnitude. His magnitude is his number, and his direction in that movie was his mission to steal the moon. So anyways, please keep that in mind. And so now what I'm going to do is, actually let me erase this. So now what I'm going to do is, I'm going to do these problems. And what this page is going to talk about is a dot product. So a dot product sounds really cool and fancy, and it's super, super simple. So a dot product, which it talks about right here, is really simply this. So listen to what I'm saying. You take the x and you multiply by the you take the x times the x plus the y times the y. That's really what you're doing. So for number one, if I want to find the dot product, I'm going to do 4 times 2 plus 5 times 3. So 8 plus 15 is 23. The dot product between two vectors is a scalar because I just have a number. I don't have a vector anymore. I don't have a direction. So my answer for number one is 23. It's a scalar quantity. So now let's try number 2. So number 2, we're going to start on the inside of the parentheses, just like PEMDAS would say to do. We're going to do u dot v, so I'm going to do negative 1 times 2 plus 3 times negative 4. Oh, that's a horrible 4. So I'm going to get negative 2 plus negative 12, so negative 14. And so I have negative 14, and then I still have vector w, so I have positive 1, negative 2, and you do the scalar multiplication thing that we talked about before, where you just multiply it in. So the answer for number 2 is going to be negative 14, comma, positive 28. So I want you to try letter, whatever you want to call it, 2b by yourself. Pause the video and then try it. Let me give you a hint. You should multiply the 2 into vector v first. So if I go to do this problem, I'm going to do the 2, like I said, first. So I'm going to do 2 times vector v, which was 2, negative 4. And so that's going to get me a vector of 4, negative 8. And then vector u was negative 1, 3. So I'm going to dot product them. So 4 times negative 1 plus negative 8 times 3. So this is negative 4 plus negative 24. And so the dot product here, when you add those two things together, is a negative 28. And so for this last problem, I need to move this real quick. And I need to highlight something. There's a box of properties that I kind of skipped over. You should know that the dot product of UV and VU are the same thing because we can multiply in any order that we want. 0 times anything is still going to be 0. This one's a little bit different. It's kind of like if you were distributing. So the U would have to go to the V and the W, so you have to do U times V plus U times W. The next one's the one I'm going to use on this problem, though. This right here. Oops, that is definitely not a highlighter. So this bottom one right here, it says that V dot V equals the magnitude squared. And that makes sense because if I have some vector V, I'm going to call it xy. xy. And I dot that vector with itself, that means I'm going to have x times x plus y times y. Well, that's x squared plus y squared. And we do the distance formula or Pythagorean theorem, we get that x squared plus y squared. So now, I'm going to use that idea to do this problem down here. Well, these problems, actually. It says that the dot product of V with itself, so V dot V equals 7. What's the magnitude of V? Well, we also know that V dot V equals the magnitude squared. So the magnitude of vector V should be the square root of 7, because what I did was I set these two things equal and square rooted both sides. So similarly, the dot product of U with itself is x. What would the magnitude of U be? Well, that means that U dot U equals x, which also equals the magnitude squared. So that means that if the magnitude of U, sorry. So that means the magnitude of vector U should equal the square root of x. Not horrible. Okay, so I know you've probably asked yourself this question. So why do I care about this dot product thing? And really the answer lies simply in the following formula, which, yes, you need to memorize. Not only do we find the angle of one vector, sometimes we want the angle between two different vectors. And to find that, we use this formula that I just circled in green highlighter. So it says to find the angle between two vectors, I'm going to do U dot V, or the two vectors dotted with each other, divided by the two magnitudes of each vector, and then I'm going to have to arc cosine that. So let's do this problem to walk through it. So it says find the angle between U and V. So the formula says to dot the vectors first. So I'm going to do negative. Oh, man. Keep picking the wrong pens. I'm sorry. So I'm going to do the magnitude for the dot product first. So I'm going to have negative 1 times 2 plus 3 times negative 4. So negative 2 plus negative 12. So their dot product is going to be negative 14. I also am going to have to find the two. I'm going to move this over a little bit. I also am going to have to find the two magnitudes. So the magnitude of vector U is going to equal the square root of negative 1 squared times 3 squared, plus 3 squared. So it's going to equal 1 plus 9 to the square root of 10. The magnitude of vector V is going to equal square root of 2 squared plus negative 4 squared. So it's going to be 4 plus 16, so the square root of 20. And so now I'm going to plug all of that together. So the formula says cosine theta equals U dot V, so my negative 14, over the magnitude of one vector times the magnitude of the other vector. And so really what I'm going to do is I'm just going to grab my calculator. I'm going to press Control Divide for a fraction. Put the negative 14 on top. Put the 2 square roots on the bottom. Please make sure that you don't put a square root inside a square root, that you have like one square root times the other square root. You should get a decimal of negative 0.989949. So what I'm going to do is I'm going to arc cosine that number. Arc cosine my negative 0.98994 blah, 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 blah. So my radian answer should have been 2.9997, but I really want a degree answer, so I'm going to multiply my answer by 180, and then divide my answer by pi. And so theta, the angle between these two vectors, is 171.87. Sorry, 87, it rounds up, 87 degrees. So now we're going to do the next problem, and I hope it's going to help you think about this for a second. So it says, let me back up. This big fancy word is called orthogonal, and all orthogonal means is perpendicular. They are synonyms. So orthogonal, perpendicular, same thing. So I'm going to hope that you know that perpendicular means 90 degrees. And if you think about the formula up here, it says to find the angle between two vectors, we're going to use cosine. So let's think about, if things are perpendicular, they make 90 degrees. So what's cosine of 90 degrees? Well, hopefully on your unit scroll you can tell me that the answer there is 0. Cosine at 90 degrees is nothing. So that means something pretty cool. So let's work this and talk about what's cool. So are these vectors orthogonal? So what we would do is the same thing I did above in blue. I'm going to do 2, because if they're orthogonal, they should make a 90 degree answer. 90 degree angle, not answer, sorry. So I'm going to do 2 times my positive 4 plus negative 3 times, nope. Sorry, I'm just grabbing the wrong numbers today. 2 times 6 times, or plus negative 3 times my 4. So this is 12 plus negative 12, and that's 0. And I can tell you right now, I know they're orthogonal, because the dot product was 0. And if the dot product is 0, then we have to know that cosine at 90 is 0, so that means they make a 90 degree angle. And if that doesn't make sense to you, then let me write it this way, because this is really what clicked for me one day. If I have cosine of theta equals something, and I'm going to have some number, the only thing up top that can make this whole fraction become 0 is if I put a 0 up top. And that top thing came from a dot product. So if the dot product of two vectors is 0, then the top of this formula and this fraction is 0. And so 0 divided by any number is just 0. And so what you have is cosine of theta equals 0. And then you're asking yourself, where does cosine equal 0? The answer is 90 degrees. That's pretty cool. So we will finish the last page of notes tomorrow, or not tomorrow, on Monday, and I will answer any questions that you have.